All right, yeah, apologies for that. All right, so once again, our gold sponsor this year is Voyager. They're working on something interesting called Starlab. So we're going to run a short video about that, and then we're going to welcome up a representative for a few words. So just take a look at this, if you will. Please welcome, for some comments, Leslie Haas, Executive Vice President for Exploration Systems at Voyager Technologies. Leslie.
Hi, everyone. Good morning. On behalf of Voyager Technologies, it's an honor to be here today. We're proud to serve as a gold sponsor of the 2025 Von Braun Symposium, which is celebrating over 2 decades as the premier gathering of visionaries, scientists, engineers, and leaders who are shaping the future of space exploration. This symposium celebrates the enduring legacy of Dr. Von Braun, a legacy built on his imagination, innovation, and collaboration of what's possible. That bold vision played a key role in the success of the Apollo missions. I saw this legacy firsthand when I first came to the Marshall Space Flight Center over 30 years ago with Rocketdyne when I was working on the shuttle main engine program and the original space station program launch. That spirit of problem solving, shared commitment, and dynamic thinking was instrumental to both day-to-day program success and overall mission accomplishment. We believe that the challenges before us today, returning to the moon, venturing to Mars, expanding commercial space, and assuring sustainability in orbit require not only technology, but teamwork, creativity, and a shared sense of purpose across the industry. Like Mercury, Gemini, and Apollo, we're at this moment in time where great things are possible, and we have the capability now, the partnership, the teamwork, working across all areas that we can make this happen. At Voyager, this can-do attitude is critical and can be seen in everything we do to advance the technologies that move us forward in space, whether it's developing next-generation propulsion systems, enhancing spacecraft autonomy, strengthening space-based data and communications, or building Starlab, which you just saw here as the next-gen state-of-the-art commercial space station. We're proud to play a role in enabling the next era of space. Together in partnership with you, and sometimes through positive competition, we're building the next chapter of human spaceflight, collaborating and mutually challenging each other to do our best and to press forth. The Von Braun Symposium embodies the spirit of shared purpose. It's here that we exchange ideas, forge partnerships, and imagine what's next. On behalf of Voyager, thank you again for the opportunity to be a part of this. Thank you.
All right. Thank you so much, Leslie, and thank you for your tremendous support of the event. I'd like to welcome our next panel to come on up and take your seats. And while you do, I'm going to call an audible here. We do have Selvi's slides. So after the break, we're going to have her do it again. All right? So you get to actually see her work. So, indeed. And, yeah, we've gone, if you don't like space these days is like the weather. If you don't like what's going on, wait 5 minutes. So we've had to adapt for this whole event as well as this panel, but we're promised a very engaged and exciting discussion. So without further ado, let's get started. This is Artemis 3 and beyond, establishing a permanent lunar presence. Join me as we welcome this session's moderator, Chris Crumley, the Principal Research Engineer at Auburn University. Chris.
All right, thank you very much. Making last-minute choices, I did ask Jim, did you have another seat at the Von Braun dinner? He said, yeah. Hey, would you moderate a panel? So there is a cost for all of that. Welcome to the panel of Artemis 3 and beyond, establishing a permanent human presence. And today I have with me Ms. Jackie Cortez, Senior Director for Civil Space at Blue Origin, Mike Lauer, L3 Harris, General Manager and RS-25 Program Manager, Mark Pond from Northrop Grumman, Senior Director for Space Exploration, and Kirk Shireman from Lockheed Martin, Vice President for Human Space Exploration and Orion Program Manager. And each of them will introduce themselves and have an opportunity to tell a little bit more about their program and their company and what they've been doing to explore the next level of where we're going with Artemis. So I'm going to turn that over to Jackie, and let's see if we can get your charts up. And I think that, Jim, do we have a clicker? I would have to stand up to get it, but thank you very much.
Okay. While those charts come up, hey everybody, Jackie Cortez, Senior Director of Civil Space at Blue Origin. If you were hoping for John Cloris, I'm not him. I'm so sorry to disappoint, but he will be here later tonight for those of you who are eager to see him instead. But I will try and do my best in his absence. I think you are all probably familiar, but Blue Origin in this discussion about Artemis, we're the Artemis 5 Human Landing System Sustainable Lander Provider. So I'll talk a little bit about that today and some of the amazing technologies we've been advancing as part of that effort, and then some of the preceding demonstration missions we have coming up that you can look forward to. So let's see. Oh, yes, okay. I did it, cool, awesome. It's the little things, you know. So to quickly touch on what we're doing at Blue Origin. So our business unit that leads all of our lunar and exploration activities is called Lunar Permanence. And it's because at our core, oh, nope, didn't do it. Did not do it. Jim, help me. No, I hit back, it did not go.
Oh, it did not go. Can you turn back one up there?
Hey, friend up there, can you and I do this together without the clicker? Yes. Can we go back? Awesome. We don't need the clicker. Okay. Up to you. Your call. Okay. So back to what I was saying. So Lunar Permanence is the business unit where we do all of our lunar and sustainable deep space exploration activities. It is led by Senior Vice President, nope.
Is the animation? The
Sir.
animation did it.
That's fine. Well, okay. Back to Lunar Permanence and John Caloris. This is all his fault, so that's okay. In Lunar Permanence, we are doing a range of lunar lander capabilities as well as enabling technologies for sustainable deep space exploration. So on the former chart before this, which you would have seen, was our lander family. So the name of our landers are all Blue Moon something. So the first Blue Moon is called Blue Moon Mark 1. It's a 3,000 kilogram class lander. It's a straight to the moon on a single launch, no refueling required, and it's fully powered by LOX hydrogen. So this is a theme you're gonna see through the history of Blue Origin is we have sought throughout the history of the company to develop a deep expertise with LOX hydrogen as propellants. We all all know the benefits of them, but we also all know the pernicketyness of LOX hydrogen. So we have at Blue Origin worked to really mature these capabilities through our new Shepard suborbital vehicle that many of you have hopefully seen, the upper stage of our New Glenn orbital launch vehicle, and then that carries all the way through our deep space exploration capabilities. So cool thing about Blue Moon Mark 1, if you did not know, is it is in final stacking right now at our dedicated Mark 1 production plant in Port Canaveral. So we have fully self-funded the first mission of Mark 1, and that is headed to the moon here in the next couple of weeks. So a big milestone for you to look out for online is that Mark 1 is 3 modules that are being stacked as we speak, aft, forward, and mid. And once it is stacked in its finished configuration, we will be barging it over to NASA Johnson Space Center Chamber A to do a full-up thermal vac campaign. So when you see that on its boat, you will know that big things are happening. So we're very excited to have that mission. And then as well on Mark 1, I will say we have a second Mark 1 in assembly in that same plant in Port Canaveral. So a lot of people don't know that the aft structure of the second Mark 1 is actually in structural testing right now. So 2 Mark 1s in that dedicated plant. And a lot of people ask, well, is Mark 1 just for demonstration? Like, are you just trying to prove out, BE7 and your other key components for your human landing system work? Great question. But no, we do intend for Mark 1 to be a product line. So that first Mark 1 is, intentionally not carrying 3,000 kilograms of payload because it is a demo flight, right? It is censored. So many instruments, so many sensors, PSI instrumentation with NASA, et cetera. But that vehicle itself is intended to grow into a production line, and we recently were awarded the Viper mission in partnership with NASA for that second Mark 1. So very excited about Mark 1, not just as a test bed for what we're doing on HLS, but as its future for logistics, infrastructure, and big permanence on the moon. So very excited about Mark 1, so stay tuned for the boat. Boat's a big moment, so hang in there for that. And if we were back on the previous chart, you would see our Mark II lander. Oh, thank you. Yes. Our Mark II lander is our crewed lander for the Artemis 5 human landing system mission in partnership with NASA. And as you can see, Mark 1 in and of itself is a large lander, larger than the Apollo lunar module. But Mark II is even bigger, about double the size of that. And for the Artemis 5 demonstration mission, we'll be carrying 2 crew on that lander. And to quickly touch on the ConOps for that before I go to the exciting next charts that you haven't seen yet, that ConOp is, that second stage of New Glenn I mentioned to you all earlier is a LOX hydrogen stage, right? So what that does is it provides propellant to a vehicle called the transporter, which is tanks, a cryocooler, and more of those BE7 engines that you've seen multiple times now. So that transporter vehicle keeps these propellants cryo-cooled, and it fuels the Mark II lander. So that architecture is our Artemis 5 architecture to meet those sustainable NASA requirements that we bid to for the Artemis 5 mission. So you might be saying in your head, which would be fine, well, hydrogen's hard, cryo-cooling's hard, and propellant transfer is hard. Understood, but that is why we've been working super hard on it. So if we go to the next chart, we won't dwindle here. But one cool thing about the BE7 video that you're seeing here, you've seen it multiple times, but just to comment on it, that's a 17-minute BE7 test, which is the apogee raise maneuver for the Mark 1 mission. So we actually have BE7 hardware currently on 4 test stands, 1 here at NASA Marshall, 2 out in West Texas, and 1 at our vacuum test stand in Edwards Air Force Base in California. So BE7 is powering along here, and as you heard, it's the core of everything we're doing in Lunar. So great progress there. And then on to the next chart. Thank you. Cryocooling, very important. So Blue Origin has been working to mature our cryocooling capabilities over the last several years, and we're now holding with proto-flight hardware 90 and 20 Kelvin in lab environments, and we have some big upcoming milestones for that. So we worked with NASA super hard this summer on this test campaign that's pictured here. So making hydrogen and oxygen storable propellants, we're making big progress here with this cryocooling technology. And then last chart, and then I promise I'm done. What you're seeing here is the Blue Origin Utility Transfer Mechanism test at Test Stand 300 in partnership with NASA Marshall. So you're hearing a lot of NASA Marshall Blue Origin collaboration. We're big Huntsville fans. Talk to me about it afterwards. I'm obsessed with Huntsville. And what you're seeing here is that test in Test Stand 300 exceeding all of our expectations from a propellant transfer expectation standpoint. So great work with NASA Marshall, big work underway on all of these sustainable capabilities. I think we can all agree that cryo cooling and propellant transfer is definitely the future of sustainable spaceflight. So we're hard at work on it for Artemis 5 and beyond, and yeah. It's awesome to be here with you, and sorry for my issues with the clicker. Over to you.
Thank you, Jackie. You did a really wonderful job moving back, and John got you on that one. So we'll tell him that tonight. So, Mike,
Thanks, Chris. Okay, see if it takes rocket science to make this thing work. Let's see. While it's coming up, I'll introduce myself. My name is Mike Lauer. I am the general manager L3 Harris Aerojet Rocketdyne, and also the program manager for the RS-25 rocket engines that are on Artemis 1, 2, 3, and beyond, the core stage. So let's jump into I had to add a chart for Artemis 2. We can't forget what we're about to go do. This is the first vehicle that has been capable of carrying human beings to the moon in 50 years. And so we are ready for Artemis 2. L3 Harris has a huge amount of content on the Artemis mission, on the SLS rocket vehicle. We have 39 propulsion elements. We have 31 avionics boxes. We have 26 tanks. We have, even on board Orion, we have a thing called the Orion audio system, which is like an audio communication device. We are laser focused on the safety of the crew. Some pictures there. You see Commander Reed Wiseman and pilot Victor Glover, Christina Cook, and our Canadian astronaut, Jeremy Hansen. And so we never forget why we're here. And, you know, at Aerojet Rocketdyne, we've flown space shuttle missions, and we know how to fly people in space, but you never can forget what it means, and this preoccupation with failure and making sure that everything is right. And so we're laser focused on getting ready. Our engines shown there, 3 of them have history in the space shuttle. The one, like 2059, has 5 flights, was flown. It was on the second to the last space shuttle mission. It helped build the space station. Our most experienced engine, 2047, was also on the final mission of the space shuttle, and it flew 15 flights. We also have a brand new engine there, engine 2062, and we tested that out at Stennis Space Center and checked it all out, and so it's ready to go as its first flight. And then the other one, 2061, which has got a couple of flights. And then on the right, the lower right, is the interim cryogenic propulsion upper stage, which has our RL-10 engine made out in West Palm Beach. That's a huge history of that engine going back 60 years. LOX hydrogen engine, amazingly high performance, the highest performing engine in its existence. And so, yeah, so we're really focused on coming up on this flight. But this is about Artemis 3 and beyond. So I'll go to the next chart here. So what are we doing? Many of you may know we are reusing the engines that we recovered from the space shuttle program for Artemis 1, 2, 3, and 4. And so we have the engines in our hands at Stennis Space Center stored, ready to go for the Artemis 3 and 4. And we will be shipping the Artemis 3 engines out to Kennedy Space Center next year, probably early next year, mid next year, where we will install them into the core stage engine section that was just delivered to the vehicle assembly building in KSC. And it'll be installed in a vertical orientation. The main effort back at my factory in California and then out at the Stennis Space Center is the engines for Artemis 5 and beyond. Just last summer, we certified the new version of our engine, where we basically took the Space Shuttle engine and redesigned it head to toe, restarted our supply base with the main intent to reduce the cost of the engine, to take part count out, use new techniques like additive manufacturing. We use techniques we derived from the RS-68 engine, which is a LOX hydrogen engine that flew on the Delta IV Delta program. The picture in the middle is the second engine made for Artemis 5. That's only a couple weeks old. We just hoisted that up onto the test stand, the Fred Hayes test stand at Stennis Space Center, and we'll be getting ready to hot fire that engine in a few short weeks. The picture on the right is the first of the Artemis 5 engines that we hot fired this summer. First brand new engine. You know, a lot of suppliers, a lot of brand new suppliers that we brought on. And so that's a huge milestone for us, as you're building up these machines with all brand new parts, new designs, and getting through that test just painlessly. Just a beautiful test. I'll move to the next chart here. So looking out on Artemis 3, you know, you'll hear more about Orion. Nice, beautiful picture there. If you look at the far upper left, you can see the edge of the Orion main engine that we provide, and also some thrusters at the end. We build engines all the way from the very large to the very small. Orion's attitude control thrusters are made by our Redmond facility, L3 Harris Redmond. And so we're, like I mentioned, all over that mission and looking forward to pursuing to the moon. A big thing for us when we look out forward that a lot of people maybe don't know at L3 Harris and Aerojet Rocketdyne, our history is rooted in power systems, and in particular nuclear power systems. In Canoga Park, actually the facility where I sit used to be Atomics International. And Atomics International and Rockwell built nuclear power, ground power systems, and space power systems. One thing, we are the prime contractor on the multi-mission radioisotope thermoelectric generators, the MMRTGs, which are powering both Curiosity and Perseverance on Mars today. Those programs, we're working closely with JPL and the Department of Energy and Idaho National Lab, so we have all of this nuclear history. Rocketdyne flew the first and only nuclear reactor in space, called the SNAP-10A back in 1965. And so looking forward to the moon, where we're really looking at, and you've all heard it in the news, and the importance of nuclear power. Any sort of outpost in space is going to demand power. The International Space Station, it had about a 215 kilowatt power system made by Aerojet Rocketdyne as the prime contractor of the space station power system. So we're working on the nuclear power system to be used on the moon to power a moon base. That picture on the right is an artist's rendition of a 40 kilowatt fission-based power system that would be on the moon. We are partnering with Westinghouse on that. So like 40 kilowatts, that would be like enough for about 30 homes in the United States. But so anything we're talking about on any outpost, power is going to be key, and certainly for Mars and beyond. But in particular on the moon, because the moon has a 14-day night, it's kind of tough to deal with solar in that situation. So it's almost inevitable that you have to use a nuclear power system in order to power that outpost. So that's where we're really looking forward, and we really believe that sustained presence on the moon, not just going and leaving, is critical. It's critical to our science and our exploration, but critical to our national security. And you've heard a lot about that in the news. So we're really looking forward to Artemis and beyond, and we're developing our engines all the way out to Artemis 9, including Orion main engines beyond Artemis 7. And so we're well ahead trying to get ready so we can build the pace of launches to support this continuous presence on the moon. Thanks.
All right, a lot going on over there, and I really appreciate the ICPS being on there. That's really close to me, so good on that one. Now we'll turn it over to Mark. And Mark, back when I worked shuttle, the engine guys always said, well, you drink liquids, and the solid guys said, well, you eat solids. And I know Northrop Grumman's got a lot more going on than that, but I know the solid program and all the things that you have going on. So tell us about what Northrop Grumman's up to.
Yeah, we used to say that drink liquids and fly solids.
I never knew what it meant, but
It's all good. So my name's Mark Pond. I've been with Northrop Grumman for about 27 years. Started as an engineer out there, and I've worked through different areas of responsibility up to the senior director. I've been in my current position about 2.5 years. My content that I'm responsible for is the solid rocket boosters and the launch abort system. And so what you're seeing here on these slides is the Artemis II solid rocket boosters and the core stage on the left, and then you see this really cool picture of Orion, and you think, why is Mark talking about Kirk's stuff? But we also do the launch abort, and so the launch abort is on the top of that. Well, I think it's the coolest piece of hardware on that Orion stack, but I'm just kidding. But it does provide the opportunity for the astronauts to get off if something goes wrong, and that's incredibly important. As Mike talked about, our main objective is to make sure that those 4 souls come back home and tell us their stories, because we want to hear them and we need to hear them. That exploration is going to be, human exploration is going to be fantastic. So Artemis II, we shipped those motor segments and aft skirts to the Cape in about September of 23, and we've been working through stacking, integrating into the rotational processing and surge facility, and then working with Amentum. Amentum is the prime contractor to go do all of the stacking work, and so we've been supporting them to build up our boosters. It's been really fun to have a front seat to this rocket. Mike and Kirk and I, we get a Saturday morning meeting every Saturday morning called the Lunar Flight Group, where we meet together with several other people from the NASA team and other contractors to break down the barriers to make sure that we're ready to fly early next year. Artemis 3, so Artemis 3 and beyond, where we are is the Artemis 3 boosters are complete. The launch abort system is complete. We're ready to ship the Artemis 3 boosters early next year. Right now we have a date with Amentum in March to ship those solid rocket motor segments out of Utah, and then the aft skirts will go over just a little bit before that. And again, we are complete with Artemis 3 launch abort motor as well. As far as what our history or what our future looks like, we have enough hardware to build the current design up through Artemis 8, and then we are building, also working on a development program with our next generation booster. We had the Boley DM1 static test back in June. Those of you that like to see cool videos, if you haven't seen that video, I'm sure most of you have, but we were able to learn some things there. That rocket performed exactly how we expected to from a rocket performance, a vehicle performance, but we had some risks. We knew we were pushing the boundaries of what that rocket was able to do, and we had some risks, and one of those risks was realized with the nozzle. We've learned a lot about that. We've learned why the hardware is speaking to us, and we've learned why that happened for the most part, and we're excited to go figure out how to get better with that. So we also are responsible for the habitation and logistics outpost. That is built by some of my friends within our division, within the Launch and Exploration Division, and in our Civil Space and Sciences business unit. They also build the Cygnus. Sorry, I think I'm supposed to do this, huh? Yeah, so there's the Boley. By the way, that's a really cool Boley test. But you're going to be seeing a pretty cool video of the HALO, the Habitational Logistics Outpost that we put together. And what you just saw, I'll say, being jettisoned from it, which isn't real, but is the power and propulsion element that's being built by Maxar Technologies. But Northrop Grumman is building HALO. So while I'm going through some of my notes on HALO, you can watch that video. In 2025, the Gateway International team has made huge leaps in progress toward Gateway. We received the HALO, I'll say shell, from Thales Aliena Space. I think that's how you say that. I don't get to go to Italy very often, but in Turin, Italy, and now it's being outfitted and getting ready for launch. HALO offers a pressurized living quarters for astronauts, and it's essentially the brain or the main hub of the Lunar Gateway. So one of the cool things about HALO is, in addition to it being the main hub, and we get to do a whole bunch of science on HALO. It hosts a bunch of science investigations. And what I've learned, I'm a rocket guy, so I'm learning about HALO and I'm learning about spacecraft. But what I think is interesting is that if you want to get anything on HALO or maybe even on Gateway, you have to come up with a really, really cool acronym that comes from Greek mythology. So if you want to work on Gateway, just start thinking about that. There are three experiments that will be performed on the outset of HALO. One is called Hermes, and I'm going to use my notes here. Heliophysics, Environment, and Radiation Measurement Experiment Suite. I can't say that 5 times quickly. But it studies solar wind and the Earth's magnetail from polar NRHO orbit. It measures low energy radiation particles. So some cool science there. And then ERSA, European Radiation Sensors Array, and it measures high energy radiation particles. And it's going to be focusing on how we protect humans from deep space radiation. And then finally, IDA, the Internal Dosimetry Array, and that measures radiation inside the actual HALO module. So protecting the astronauts and the components from deep space radiation is obviously a huge part of what we need to learn going forward, and how we can live in the deep space environment. What we're doing in the future, we are trying really, really hard to minimize our costs, to lower our costs while still providing an effective element and effective content for our NASA customer. In the booster world, we have developed and signed up to a fixed price contract, fixed price incentive fee contract, and we're succeeding with that. We have a new engagement model with our NASA counterparts, and my NASA counterparts, I have a couple of them right up there. I can see them. They're making sure I don't say anything stupid here, but we have this engagement model that allows us to have the design and MRB authority, and we're moving faster as a result of that, and they're right along with us, and we really appreciate what they do. Additionally, we're really trying to minimize how much work is done in the VAB, recognizing that needs to be very, very quick to market. As to build up a rocket and send it, we need to minimize as much work as we can. So just a really good example of that is those really cool worm logos that you see. Artemis 1 and Artemis 2, they were painted at the Cape. They are being painted in our factory. We're also looking at different other opportunities to minimize the work in the VAB, or I'll say not minimize, but at least reduce the work in the VAB so that Amentum can reduce their timelines. And then from a HALO perspective, HALO has a lot of cool things that will help in the long term. HALO's computer systems, they can detect issues, respond, and fix them themselves. So they don't necessarily have to have that human element. And then HALO also have advanced communication and video systems to support communication between the moon and the Earth. So really excited to be part of this. I'm really excited to be part of this, and really excited to be part of the bigger team. I love the Moon to Mars team and some of the relationships that I've made.
I appreciate that, Mark. You got a lot going on over there, and really some cool names there in the Halo. Maybe not as catchy as the Ninja Turtles we had with the MPLM,
Yeah,
but
yeah, probably not.
really up there. And thanks for you guys giving some love to Kirk down there on the table by himself. We didn't do that intentionally there, Kirk, but you've got so many titles. You probably have titles of 3 or 4 people, but I know you've got a lot going on, so tell us what's going on.
Hello. Oh, it does work. You have to push a button, though. It's like a clicker. Anyway, all right. Hey, great to be here. Thank you for having this panel. Thanks for the opportunity to speak to folks today. I'm very excited about the Artemis program and what the future holds. One of the things you probably know, but I'll say it anyway, is everyone up here has their own thing. They're talking to you about it, but the success of any one of us or an effort really depends on the success of everyone. So actually, none of us will be successful unless all of us are successful, and I think we're all committed to that. You know, Mark talked about a group that gets together every Saturday morning, although I did think that LFG stood for something else, but we'll go with that. Yeah, let's go fly is what I use, but that's not exactly right. Anyway, but seriously, we actually work very hard to help each other out along the way, and we're rooting for each other. I can tell you that for sure. So Mark showed some pictures of Orion, and the cool thing is his launch abort system does sit on top. It's the highest point. It is a really cool piece of hardware. Technologically, it's actually really cool if you want to get into the details. I hope we never use it, actually. I'm glad for it to punch a hole in the atmosphere, but I hope we never actually fire that thing. By the way, it also makes it really hard to do everything else in Orion. That kick in the pants you get when you light that solid off pretty much is the design environment of just about everything on Orion. It's quite the acceleration for about 6 seconds, and that thing makes everything hard on Orion. So anyway, necessary. By the way, I've seen one work, October 18th, October 11th, 2018. I actually saw a Russian launch abort rocket save Nick Hague, one of our American astronauts on that Soyuz. So hope we never use it, but I thank God we have it up there, and I know that it makes us all easier watching that launch. Let's see, let's go to the next page here. I wanted to introduce myself, and I thought a family photo would be a great way to do that. Here's our family. Really, the point here is we have quite an extensive number of spacecraft that have flown or are in work right now. We have EFT-1, which flew a number of years ago, Artemis-1 that you see on the left-hand side of the chart, and then you see the others. They're all actually down in Florida in various facilities going through the manufacturing and tests. So quite a bit of hardware in flow right now. I included the next page here. I know this is about Artemis 3 and beyond, but part of this is Artemis 3, just so you know. This is our heat shield. Quite a bit of work was done here in Huntsville on the heat shield. We had some discovery on the Artemis 1 heat shield with some flaking of that AVCoat blocks, and we did a tremendous amount of work. We, NASA, and really experts around the country did a lot of work to understand that technologically. We think we have it well understood, and we have come up with a new formulation of AVCoat to stop that. We actually had an Artemis 3 heat shield built. We sent it here to Huntsville, and they machined off the AVCoat, sanded it back down to the bare epoxy of that carrier structure, and now we've actually glued the new formulation of AVCoat on it at KSC, and you can see various pictures here. So heat shield's in great shape. We're actually starting on the Artemis 4 heat shield right now. A little video here. Hopefully this plays automatically. Oh, it does. Here we go. So when we talk about, oops, what happened? Here we go. Try again. There we go. So we talk about Artemis 3 and beyond. I like to look really far out into the future. In order to be successful, we, and I talk about we, really, I'll say we as a species, certainly we as a country, need to do a number of things. We really are going to go beyond Earth and live in other places. We need to have a sustainable idea of how to go do that. And when we're at the very beginning, it's pretty precarious. So when you look at Artemis 2, really Artemis 3, going back to the moon, there's pieces of infrastructure, but our ability to stay on the moon long is not really there yet. So we have to have all these elements here as we go forward. In the order in which you build these elements and the size of which and when you build them is all really important. A number of these elements are actually in work now. So you see mobility. I know there's a number of companies, I saw at least one of them here represented today, working on lunar mobility. We're going to have to move things around on the moon, no question. You have to have mobility. You have to have a good transportation system. We've talked about the rocket, you talked about Orion, we talked about the lander. You have to be able to land both people and cargo on the moon. You have to have power. There is solar power. You can use solar power on the moon. It works awesome for those 14 days. Depending upon your latitude, where you are, I agree with Mike. Ultimately, you have to have nuclear power. So if you look in the lower right, that's a rendition of what a nuclear power plant would work. Space nuclear, by the way, that's a whole different topic, but space nuclear for lunar surface power is critical for our future. I really do think space nuclear propulsion is critical for us as a species, both for human exploration and ultimately for robotic exploration. I think we're on the cusp of the nuclear age in space, so looking forward to what happens there. It really is key to actually doing what we're going to do with Artemis 3 and beyond. And then in space resource utilization, ultimately we can't launch everything that we need. It doesn't make sense. You certainly can get away with it in low Earth orbit. We've done it for 25 years on ISS. You might be able to get away with it for a little bit on the moon, but ultimately you want to be able to use the resources there. And certainly when you talk about going beyond the moon, no question, you're going to have to be able to use the resources that are provided at that location. So anyway, all these things we need to do here in the moon. And the beauty is they actually apply, if we do it right, those also apply when we go on to Mars. And so every one of those things that we just talked about, transportation, habitation, mobility, communication, navigation, power, ISRU, all have to be there. Now, the fact is, you all know the right half of that chart's still a quantum increase in difficulty and risk. I always tell people, why is going to the moon harder? And the real answer is when you're flying on an airliner, something goes wrong, your engine dies or whatever, you're 30 minutes from being on the ground. If you're on the International Space Station and something happens, you have to come home, you're okay, an hour and a half, 3 hours from going home. When you're on Orion and something goes wrong and you have to come home, you might be 6 days from coming home. When you go to the moon, you hit the abort button. A year and a half later, you're coming home. So the amount of robustness, the amount of risk, and the reliability that the systems have to have is really, really a quantum difference. It is for the moon as well, and that's the one we're trying to do now. So I think Artemis 3 and beyond is really critical for us to set the stage for our children and grandchildren to do the right half of this chart. So very excited to be part of the discussion today and look forward to your questions for Jackie, Mike, and Mark.
All right, I caught that, but I'm not going to catch the ball. By the way, all of you be thinking about your questions, and if you don't have any questions, I know a lot of you, I will call on you. But I'm going to start with the first question, but let's talk about our theme. I mean, Artemis 2 is set to launch in just a few months. Artemis 3 is going to return humans to the lunar surface. What has been accomplished and what must take place to get to lunar permanent human presence? And one of the things that I thought about when I was preparing for this panel was, how is the Artemis roadmap similar to when we established permanent human presence on the space station? And how is it different? So Kurt, I'm going to go right back to you because you and I have worked on this program for many years.
Yeah, thanks. You know, it's a great question, especially today. You know, the first humans actually crossed the threshold. It was November 2nd, 2000. So here Sunday will be the 25th anniversary of the first humans to live and work on the space station. When I look out in the audience, I see some people here who probably never known a time in their life when people weren't living and working in space. What a phenomenal thing that is. And I hope that in the not too distant future, we'll say the same thing about the moon. So it's kind of exciting to be part of this program. So I think so when you let the path for ISS, you talk about the path for Artemis, you know, those first few flights that happened for ISS were really critical and I'll say fragile. You know, there's this concept of anti-fragility, really, and that kind of applies to ISS for quite a few flights. You really needed things to go your way. You needed those flights to go off. You needed them to go off about when you planned them, and you needed them all to be successful. And that is what happened. I think that's the same thing that we talk about here. You know, the first flight of ISS was November 20th, 1998. The FGB flew out of Kazakhstan, and then we flew December, I think it was December 3rd of 1998 was the first orbiter flight, and it brought up a node 1, up to ISS. Those things worked great. When the crew came in, they had to come in and they had to do a bunch of work in a really short time frame, or they would have to come home in order to get things started, get the ECLSS system and so on going on. If you look at Artemis, I think it's those same kinds of things. We need all these elements to work and be successful. We need them to go off on about the right time. And there's a ton of dependency on each other, like I talked about a minute ago. So all that has to happen. It's very similar. You know, the details are different, but the fragility is the same. And then as we build up, we have to design. All of us have to design in and execute things that make it less fragile as we go forward. And I think that's really where we're going. You heard it in the talks here, certainly in the charts I was showing. All those things really help us be more robust in ability to withstand you know, the bumps and valleys that we're going to inevitably face as we go forward here. So I think it's really we have a great plan. We got to execute those plans, and we have to roll with the punches as we go forward.
Yeah, and you just kind of briefly touched on it. International partners was a new thing for us, and how that, and I believe that we will see that on the lunar infrastructure as well.
Yeah, no question. Of course, the European Airbus and ESA are part of Orion with the service module. If you look at Gateway, a lot of the elements in Gateway are by Canada, Japan, Europe. So yeah, and now the United Arab Emirates. I think as we talk about Artemis going forward, it has to be that way. We're doing this for the species, not just for ourselves. Of course, I have to say we're doing it for ourselves too. We're doing it for the United States of America. We're the leaders here, but I think we're trying to build a strong coalition of the willing to go create this future for us all.
Yeah. Okay. Others on the panel? Mark, anything?
I'll just say probably the biggest thing that I see that we need is machines. We need a whole bunch of machines. I'm a big fan of World War II, and our head of Moon to Mars, now the Associate Administrator, Amit Satria, talks about the arsenal of democracy, and I keep talking about it, but the arsenal of democracy in World War II was all about building a whole bunch of machines so that we could go win the war in World War II. And we need that. We need a whole bunch of machines. The cool thing is for instance, Halo, and then we need to learn what we need to learn in those environments. Halo is a fantastic, and Gateway is a fantastic tool. It's a fantastic machine that we're going to be able to use to understand deep space radiation. We're going to be able to understand what that means to people, what that means to machines, what that means to long-term exposure, and how to protect against it so that we can get on and get to Mars.
Yeah, before you pick up, Mike, I just want to just hit on that thing about the machine. Students, did you hear that? machines, and that requires engineers, technicians, business people, procurement, acquisition, government professionals. So the future is bright, according to Mark. All right, Mike?
I'll just add real quick. I mean, the machines, as it said beautifully, Mark, we must increase that launch rate. We must increase that launch rate, and that it makes your team sharp, and you move. And I remember at the beginning of the space station program, the fragility of those first flights, and then we started getting on a pace. We started assembling all those elements with the space shuttle. So this beginning phase, we're spread out. We got to speed up that launch rate, and we need all these machines, all these engines, these rockets built up so we can maintain that pace. Critical.
You kind of stole mine a little bit. I was going to say we have to up the frequency, I think, in a big way. Obviously, still being laser focused on safety, but we really need to up the frequency. I think on the launch side, we've seen, especially, led by SpaceX, the availability of launches has completely changed the space game, and I think the same thing will happen here on the moon. Once we up the cadence of the landers of all sizes, that's going to really unlock a lot. And then we talked about it earlier a little bit, living off the land is going to be a key enabler. At Blue, we recently opened a Space Resources Center in Los Angeles where we're doing molten regolith electrolysis work for the future of ISRU on the moon and Mars. And so I think those two sides in the near term, really upping the frequency of missions and the availability of opportunities to the surface. And then on the long term, not forgetting that if you want to achieve things like ISRU in the future, you have to keep going with it now in a very robust, really robust mission, or else you're not going to get there in the end. So that's all I would add.
All right. Well, let me try something different. Mark, if it's okay, I want to start with you and come back down the panel. And you hit on this a little bit, but what innovations are in store for us? What are we going to see over the next decade or two or three?
Well, so the first thing, and I was hoping you'd ask me that question. The first thing is you need a really big rocket to get off the ground. And our next generation booster, the booster that we tested back in June and we're developing, is the one of the key critical components that we need to go get to Mars, get to really deep space. The other thing is there's something about just showing up, right? One of the big keys to success that I tell my kids and people that work for me is you got to show up. You got to be there. We have to be first. We have to show up. We have to succeed. We have to get out to cislunar space, and we just need to learn. There's so many things that we're going to need to learn from cislunar space as well as the surface. There's so many opportunities, I believe, on the surface, and so what that looks like in the next 10 years or so is all going to depend on our ability as a nation and as contractors and as NASA and others to focus on the importance of what is coming and how we kind of get ahead of it. If we can keep our focus and funding and all of those things, I think we have a great path to succeed and learn the things that we need to learn so that we can be long-time explorers.
Okay, Mike?
What I think is manufacturing technology. There are so many new ways of building parts and making things. The range of additive type manufacturing that we're using and we're implementing on RS-25 engines as sort of pathfinders. Manufacturing technology, the use of AI in design, the use of AI in operating machines. That's where, as we're squeezed to the launch rate and pushed to do these hard things, go to the moon, that's where I see we're going to see all this happen. And all that technology, you hear about it, it's out there, and the key is to on-ramp it into these systems safely so that we can safely fly people on them.
I think I would just hit even a little bit more too on the robotics, AI, and manufacturing to rate, now kind of conversation. So at Blue, we're really focused on manufacturing to rate across all of our programs, and that does include heavy additive manufacturing. We're learning to incorporate AI. That's an area where we're looking for really unique partnerships in academia and other industry partners, maybe in other sectors that are AI experts, where we can bring some of that in. And then on a robotics front, we're doing some really cool things that I think will help us explore the moon and Mars even more. So our subsidiary, Honeybee Robotics, is making a fully autonomous mobility platform through the CLIPS program to support an upcoming Firefly mission. And some of the really cool next-gen things they're able to incorporate around AI and around robotics is going to be very, very cool for that. So yeah,
Okay.
agree.
All right, Kurt. And as we talk about innovations, what about the risks also?
Sure, yeah, it's funny because you talk about AI, it is changing, certainly our industry, it's going to change the world, but we need actual intelligence as well. And that's to manage that risk. You've heard stories, in fact, if you've played with it a little bit, you've had experiences where you get something that looks really very real and is absolutely not and wouldn't work. And so we still need engineers, we still need scientists, we still need all those degrees that people are working on right now. They're still needed. And in fact, maybe even more critical, because you're going to have to be able to look and discern what's real and what's not, and make sure that we're doing these things carefully, safely, and ethically, I think, is going forward. So tons of challenges just in that domain. Relative to the question at large, though, I think the one we didn't really touch on in that answer, but I think is really important, is space nuclear. We're gonna have to put, and that's much trickier than putting a nuclear reactor here on the surface. It's probably a technical discussion all to its own, but both nuclear power and nuclear propulsion, both very, very challenging, but I think we're about to crack that nut. And then the last one I wanted to throw in too, ultimately none of this is going to be sustainable without business. In other words, there has to be a way of fostering, of making money of as we go forward. And I think business innovation, the ideas that people are going to dream up to go make money doing what we're talking about. How do you do this and make some money while you're doing it? That's going to be fascinating and really exciting to watch. I know, at least in my career, the ideas and the proliferation of companies that are coming up with ideas and pursuing has been fantastic. I think that's one of the strengths of the United States, really, is that anyone can come to the table with their idea and basically spontaneously innovate and change the industry. And we've seen it already. I think we'll see it at an increasing pace going forward. So exciting to see what's going to happen, not only from building that infrastructure, but utilizing that infrastructure in other ways to create value.
It sounds almost like a plug for Christian's book. We need to go in and get that and read it. And also, if there's any lawyers in the audience, we're going to need you guys too, because there's at least 3 bureaucratic agencies that will have something to do with the launch of nuclear when we finally do it. And it's a formidable challenge to get through there. So Mike, I'm going to start with you with the next question. And how are each of you, and this is for everyone on the panel, I'm going to start with you, Mike, how are each of you leaning forward in new developments for a sustainable lunar colony? And what's the lunar ecosystem that we're going to create?
Well, first, the lunar ecosystem is absolutely an international ecosystem, and so collaboration internationally is absolutely critical. For L3Harris, I mean, it is that power development and utilizing our history to hopefully help provide the power systems, the nuclear-based power systems. And we also have a lot of history in the nuclear thermal propulsion. And nuclear electric is propulsion. One thing we do is the very large electric motors, electric rocket, which we'll need. And then our advanced electric motor will push the gateway out to the moon's orbit. And so that's another area. So yeah, Support of that ecosystem is really for us, how do we can make a reliable power system that is safe and incredibly reliable and also maintainable on the surface of the moon at this distant outpost, this distant colony that, where it's going to be less easy to communicate and has to be more self-sufficient. And that self-sufficiency Kirk was explaining, is absolutely critical for Mars. They have to, at Mars, it's absolute self-sufficiency. And so pushing toward that maintainability, self-sufficiency is where we're focusing.
All right. Jackie, pick up?
Yeah, I think I hit on a lot of this already, but just to cover some of the areas where we're investing our own resources and focus into sustainable deep space exploration. I mean, the core of it is the transportation. We've self-funded the development of the New Glenn orbital rocket. We've self-funded the development of the Blue Moon Mark 1 lander because we believe that these are the core building blocks of achieving that frequency, achieving the path to sustainable lunar and ultimately deeper space exploration. I hit a lot on the cryocooling and propellant transfer, especially when it comes to LOX hydrogen. We do think there is a LOX hydrogen economy in the future here to be had, so we're really focusing on that. And then there's a lot of other little things we're working on across mobility. I mentioned Honeybee Robotics. If you're not familiar with them, they are the preeminent off-planet operating company through drills, actuators, other core components of most on-surface, off-planet things that have happened. They also are developing the Lunar Vertical Solar Array, which is really cool. So you implement one of those into a Mark 1, and you have a pretty sweet power node that you can drop anywhere on the moon, day, night. Things like that. Our Blue Ring platform is also working on comms, and it may sound like we're dabbling in a little bit of everything, which we are, because we think this infrastructure is super important to the future. But even if we're successful at all the things that we're doing just at Blue that I mentioned, that's great. But to Kirk's point, we need so much more than just what we're doing at Blue to create this ecosystem. So those are just some of the things that we're focused on for sustainability, but definitely looking to partner, provide that transportation for other people with great ideas. And the last thing I'd mention, because it's often not brought up in this conversation, but all of our work on the New Shepard system, self-funding that, getting it operating, flying people to space on a near monthly basis right now. I think it's pretty amazing that we live in a day and age where someone can buy a ticket and go to space, not just a professional astronaut. And I think to underestimate the impact that will have on people and the downstream effect of that would be wrong. So that in and of itself has been a test bed for lunar technologies and a test bed to open people's eyes, the average person's eyes, to what a future in space could look like. So that's what we're working on.
All right. Hey, Kurt.
Yeah, probably the only thing I could add here, what we need to have a good sustainable system there is ultimately we need perseverance. Every one of us here, every one of you in the audience, and our country need to say, this is important for us to continue doing. So what we're doing now is laying the framework for this future, this bright future. But if we don't stick with it, if we don't keep pushing, if we don't get up when we get knocked down, and it sounds like a song, doesn't it? If we don't keep pushing, and moving forward, it won't happen. So, I guess my request to all of you here in the audience, and certainly of us here on the panel is, hey, look, we have to keep pushing. If we don't keep pushing for this future, it won't happen. And so, not only we need to do what we're doing as companies, but we as members of the industry and as citizens of this country need to go tell our leaders in this country, this is really important. It's hard, it takes a while, it takes some money, but it's really important for our future. Keep pushing.
Yeah. Mark?
Yeah, so a couple of things, and not only is it, I'll maybe build on what Kirk says, you talked about engineers and scientists. One of the biggest challenges that we have is there's people that actually know how to build stuff. that know how to put a wrench in their hand and actually build stuff. There's machines that will build other machines, and I think that that's coming more and more all the time. But that human element to go build those machines and developing that human capital, if you will, to go do all of the things that we need to do in an engineering standpoint and a scientist standpoint, but as well as those people that are actually putting their hands on the hardware, I think is incredibly important. And it's not going to be, I think we're going to have those people for a good long time. I don't think that we're near the point where a machine will always build a machine. That human element is incredibly important, just like the human element is incredibly important to send to space. There's something about that human element when we see humans just like us, maybe a little bit shorter than me and maybe a lot more fit than me, but just like us flying in space and having that permanent presence. It's going to be a fantastic experience. Now, how are we leaning forward? I think the big thing that we're trying to do is focus on our execution, especially on my team. That execution, meeting our contractual milestones, meeting those things that we need to go meet, so that when NASA needs those machines and when they need more machines, we have good objective evidence that we met our commitments to our customers and to our nation.
All right. Not disappointing with this panel with their good answers to these questions. Now it's your turn. And the microphones are coming up, and I think we're going to go both sides. And I see a dozen questions. So, Jim,
And
you're on.
actually, I'm going to start with a couple of online questions.
Oh, good.
While we get you folks to wait. And just be forewarned, they're both from reporters. So they're looking for updates. First one is from Will Robinson Smith at Spaceflight Now, and it's a two-parter. For Jackie, can you please provide an update on the development of the HAB area of Blue Moon Mark II? And the second part is for Kirk, looking for an update on the transporter that will refuel the lander. So, Jackie?
Yeah, I could take both of those if you want.
Perfect.
Kirk. Okay. So awesome question on the HAB area. I will say that we're working hard on that in partnership with NASA. We've definitely decided to insource a lot of the ECLS and environmental components. I think that supply chain is an area where we wanted to have a lot of robustness and redundancy. I think what we were seeing was some downrange supply chain issues in the ECLS area, so we are working to vertically integrate a number of those areas, so we've made some great progress on that. That's also an area, I will say, where we found some awesome synergies between our human landing system work and our orbital reef work. So we've done some really cool work on our own ECLS technologies through the orbital reef program, and so those synergies between those programs has been awesome. So we have been making some great progress on the crew cabin and the ECLS specific insides of the crew cabin. And then on the transporter, I would just mention the transporter itself is developed by Blue Origin. The tanks itself are largely using the same processes for our New Glenn tanks. So we're using that existing line for those. That cryo cooler and the utility transfer mechanisms I showed you all earlier directly apply to the transporter vehicle itself. And then the BE7 engines are also on the transporter. So actually all of what I showed you today in hindsight is directly applicable progress on the transporter vehicle. So the last thing I'll say is, using a lot of existing lines, like I mentioned, great progress on cryo cooling and prop transfer, and then we also just opened our dedicated lunar production plant for the HLS vehicles. Confusing, Lunar Plant 2 is where we build Mark 1. That's been up and running for quite some time. Lunar Plant 1 is where we build Mark 2 and the transporter for the human landing system. Apparently it has something to do with the history of General Motors or something. You'll have to talk to John Caloris about that though, because I don't fully know. So that vehicle production facility being stood up right behind our New Glenn production facility. So if you're down at the Cape, you'll see a very, very tall new building that says Lunar Plant 1 in extremely large letters. So that's that.
Let's go to audience questions. Let's start right here.
Hi, thank you so much for your talk, by the way. I was curious because y'all mentioned additive manufacturing, and I wanted to know how has additive manufacturing affected the process in building space exploration and infrastructure? And I was curious if there's any critical infrastructure that uses additive manufacturing in use right now.
Anybody on that one?
I'll take it, yeah.
All right.
So, yeah, so additive manufacturing. You'll see there's a prolific amount of additive manufacturing. People can go out and print parts in your garage now. You could buy a metal machine and print it in your garage. Plastic, of course, is being printed. We are on-ramping. We are a good part of our engine now is additively manufactured. And it is, it's very tricky. Additive can be, that can deceive you in, oh, hey, I'm able to print this part, but its capability, its fatigue life, its fracture capability, all of those things, you have to very carefully control and monitor and prove that your processes are under control. The other thing about additive is that it's your ability to make what used to be many different little parts that you'd inspect and then you weld them all or put them all together. Now we can print it all, but now you can't inspect it very well. So the inspection and non-destructive evaluation. So, but we're really, we really think that is, we can speed up production by using additive. We've been able to take what were big welded assemblies on the Space Shuttle main engine with 100 welds and reduce it down to 3. And so getting rid of welds is a huge reliability improvement because welds are usually the weakest spot in a structure. So yeah, we're definitely pushing that, and some of the additive, the newer versions of large open frame additive, where you're not just confined to like a powder bed that has a certain geometry. You can build a part only so big. Some of these large open frame additive machines, which we are working on, but a whole lot of it is about process control. Because you can't just print in your garage and anticipate that will work. In the extreme environments, some really tight margins for building spacecraft.
Hi, everyone. Thanks so much for being here. This is about the space race with China. Why is it so important for the U.S. and our allies to land on the moon, land humans on the moon before China?
You guys looking at me?
I was going to say,
I was heading there.
I think we all can take that. But go.
I'll just say, we in the United States are going around the world and signing up people to join the Artemis Accords. How are we, as peace-loving people around the world, going to set up an infrastructure, a way of doing business, a way of cooperating on the moon? And that's the Artemis Accords. China is out there doing the same thing. I don't think those two things are not consistent with one another. It's really about how do we want the legal structure, if you will. How do we want to cooperate on the moon? That's what we're fighting for, I guess. That's what we're racing for, if you will. It's also about resources. We've seen here on the planet that China believes differently than we believe in the United States about extraterritorial jurisdiction around various things. And there are certain key places on the moon that have resources or geographically important. And so I think that's all those reasons why we want to be there. It's not about just being there for the United States and planting a flag and having a parade. It's really about our way of life and how we see cooperation, international cooperation. And so I fully support that effort. I think it's really, really important for our future, the future generations in our country, and really the future generations in our allies' countries.
Yeah, I was going to talk a little bit about the resources, but also, and again, Kirk mentioned our way of life. The resources on the moon are we know are there. Water, we know, is there. That's the ability to harvest that water and use it for sustainable life, or for propulsion, or for whatever we need to use it for is important. But just like in the Cold War, when we beat Russia to the moon, there were certain things that not only we built and we use today, but there is a responsibility, if you will, to maintain our technological leadership. And I think reaching the moon before China is a big step in maintaining our technological leadership with our industry partners and our international partners.
Okay, another media question from online. This is Stephen Clark from, I believe he's with Ars Technica. It's probably for Kirk, but has the government shutdown had any impact on Artemis II preparations? And is there a point at which that shutdown will affect the schedule?
Yeah, let's see. That's a great one. Since NASA's not here, I could say whatever I want, can't I? That's awesome.
There are some private citizens in the room.
Private citizen, yeah, good. So practically, we've tried very, very hard to not have the government shutdown impact us. So NASA has accepted Artemis II, and which means the people at NASA who are working to support Artemis II are still there. So yeah, in general, we've seen, I'll say, nuisance kinds of things. It turns out if you want to ship things, and there are some things where you need other parts. I do think we're rapidly approaching the point where it will be a significant impact, and it's more to do with overall infrastructure. Some of you flew here. I suspect if you weren't delayed coming here, you're probably going to be delayed going home. Even in the airport, going through TSA. Pretty much, literally everything that affects people's lives is affected by the government. And when it's shut down, it's going to have its toll. And it's probably going to be these secondary impacts that ultimately do it. And then finally, companies are not being paid. So they have the ability to be reimbursed at some point in time. And fortunately, I work for a large company that's capitalized, and we're going to be fine. But there are a lot of people, a lot of companies, small companies. I call them mom and pop companies, but small companies here in Huntsville and across the nation that are not getting paid. And ultimately, they're not going to be able to continue working. So yeah, not yet, but it's coming. I know it's coming. And what day is it going to hit here? I don't know. I really hope that we can find a way to get the government back up and running. And if anybody has any great ideas, please call your members of Congress today. So thanks.
Okay, let's go Jeff Faust. I think he had a question, and then we'll do some more. We're going to keep the questions going. I know this is important, so we'll keep going. Jeff?
All right. Hi, Jeff Faust, Space News. Two quick questions. Jackie, I know NASA asked Blue Origin for acceleration approaches for your lunar lander. I'm curious if there's anything you can say about what you're looking at in terms of speeding up Blue Moon. And then, Mark, did you find the root cause of the nozzle incident with the Bull test in June, and what do you have to do to correct that problem?
Yeah, thanks, Jeff. Since it's definitely a competitive environment, I probably won't say too much about it, but we did just kick off that work with NASA. We're super excited about it. We have a lot of ideas, I will say. As I mentioned earlier, our Artemis 5 approach is extremely focused on sustainability, very focused on the cryocooling, the propellant transfer architecture. But I will just say it this way, especially with Mark 1 and some of our preceding work we're doing, we have what we think are some good ideas about maybe more incremental approach that could be taken advantage of for an acceleration type scenario, which is ultimately still on that end path to sustainability, but is perhaps more incremental and near term. So since that work's ongoing, that's probably all I can really say about it, but I think we have some good ideas. So we'll see what happens.
Okay. Mark?
Yeah, on DM1, we are very, very close to understanding the root cause. We've had an investigation team working on that for, well, since the day of the test. Hardware's speaking to us. We've collected all the hardware in the nozzle and understood what the primary failure. Obviously, it was a brand-new rocket with new environments, and so we were able to learn a lot about those environments. And so what are we doing about it to fix it? With that additional understanding of those environments on a first step development test, that environmental understanding was key. And so it's now just about providing the right components on the backside of the nozzle to protect them from that, to protect them from the environments a little bit better.
Yeah, and you students that are in aerospace engineering, go and study and figure out how all these things work, because these solids are a lot more complex than you might give them credit for at the beginning, and it's a very interesting study.
Hi, question for Kirk. Kirk, you've spoken about selling Orion commercially, but I think NASA owns that system since they paid for all the development, so I'm wondering how Lockheed could sell that system commercially when it's owned by the U.S. government.
Yeah, that's a great question. So it depends on how NASA chooses to do this commercialization effort. So that's the bottom line. So yeah, we have ideas about what the technology that Lockheed Martin has developed. We certainly own the technology. Government has rights to those things. So we can use that technology, but we'll see how this whole commercialization effort that NASA has, well, really the administration's come out with in their president's budget request goes forward. But we have the technology, we own the intellectual property, we have the supply chain to go do those things. But we have the ability to do it. Exactly how it plays out is kind of in work at this point in time.
Yeah, we're starting to see a lot more, I guess, innovative acquisition strategies throughout the government, and it's been exciting to watch.
I guess, again, what's the key point is the government has rights to those technologies, government purpose rights, but Lockheed does too. So anyway, there's a lot of work to be done. There's a lot of things to be determined as we go forward, and the key is to be adaptive, to be able to deal with whatever comes forward. In the meantime, we're working very, very hard on reducing the price and increasing our velocity on building Orions. You guys saw the pictures earlier. So we're working really hard on that.
Yeah, thanks for including my chute on there. I saw the roof. Yeah.
Hi there, Jeff Wozniak from KBR. So maybe Jackie doesn't want to answer this one, but with the president's budget request where we saw that Gateway was canceled, now it's back, with Sean Duffy's direction to open up the lander competition again. I want some comments on we've seen this Artemis 3, 4, 5 plan. I want some comments on how important the stability of that plan is versus your anti-fragility or robustness to changes that could come out of Washington, D.C. to this plan, so that we can get to the moon and fulfill those reasons why. So this is more of a how question. How are you resilient to it, and how important is it to stick with the plan that we see?
Yes. I think in terms of like the Artemis 3 and acceleration conversation, I probably wouldn't add anything other than what I said to Jeff's question. And then to the resiliency of the overall Artemis architecture, I'll just, say that for our Artemis 5 contract, that's the work that we're working on right now. We were required, for example, to be able to dock to both Gateway and Orion. And so we're maintaining work on that plan. I think there was resiliency built into that, but we see a lot of a great future, whether we're docking to Orion, docking to Gateway, in terms of the sustainable future. We definitely see that full Artemis architecture as being highly sustainable for the future. And then on our side, we're just maintaining as much resiliency as possible and continuing to work as hard as we can on our existing commitments with NASA. So.
Hi, good morning. We're students from Arkansas State, and it was more like a kind of local question. So, what are you guys looking for when it comes to university research for nuclear thermal propulsion?
I'm sorry, the question was, what are you looking for? Is
I mean, what are some areas of interest that perhaps your companies are sort of kind of would like to see from universities
Sure.
focused on?
Well, nuclear thermal propulsion, you take a nuclear reactor that operates at about 2,700 degrees Kelvin, and I'm more of a rocket guy, so then you use that to heat up liquid hydrogen from 20 degrees Kelvin to 2,700 degrees Kelvin in a few milliseconds, and then shoot it out of a nozzle. That's hard. So yeah, material, you can imagine. It turns out, uranium doesn't like to stay in the solid form at those temperatures. Actually, not much likes to stay in the solid form. So materials is a huge deal. Flow dynamics, some of the early reactors, by the way, it's not Mike's, but broke themselves apart because of flow-induced vibrations. And so flow dynamics, being able to model flows, of course, you can imagine that nuclear reactor has a ton of cooling paths around it. So yeah, materials, flow dynamics, of course, turbo pumps, you still have to have turbo pumps. You have to keep, hydrogen doesn't like to stay at 20 degrees Kelvin. It wants to go hotter. And so you got to keep it at 20, you get large tanks full of hydrogen. So all those things I think are really, really critical. You have to keep a control system to keep it all operating. And then ultimately, you'd really prefer if it didn't blow up. So you probably need safety engineers to identify hazards and make sure that all of those things are dealing with all those hazards. And of course, I'm probably scratching the surface. We didn't even talk about in a nuclear regulatory agency and FAA and
how hard it is to test this stuff on the ground.
You typically can't test it on the ground because everything gets much worse from a radiation standpoint. Lots of technologies there, really. It just could go on and on.
Mike, you want to hit that one?
Well, I mean, the other one's heat transfer. I mean, in a rocket engine, it's like we have temperatures 6,000 degrees, and within millimeters, we're in cryogenic temperatures. So understanding that heat transfer and the flow dynamics and the way heat moves, those are, if you study that, then you are set up for the business of rocket engines and nuclear reactors. But yeah, a nuclear thermal propulsion is super cool. It's the mixture of rocket engines and nuclear, and it's a really exciting thing to study.
So I know we're out of time, but as the moderator, I still have the mic. Some of us joined this great adventure following the Apollo program. I was 5 when Apollo 11 landed. I might not have understood everything, but it still attracted me to the space industry. So I want you to picture yourself watching the crew take those first steps on the moon. Where are you? Who are you with? What are you thinking? And what are we doing to our nation and how we're moving forward and for the world? So this is an exciting time, and I'm just proud to be a part of it, watching from the outside to see how it all goes. So thank you very much. Thank you for the panel. Please give them a great hand.